Hello, welcome to this video, and in this video we'll be doing the bioleaching process. So maybe I can just write it down here. This question is on bioleaching, right? It's a sort of a mining process which uses biology. Okay, so the miners these days extract gold and all those by using bioleaching, and that's what the story they tell you here. So let's do the question now. Okay, so when the gold is associated with minerals and iron sulfide, the sulfide must be oxidized to release the gold particles. Okay, you can read this. So what happens actually is this Fe2 plus, okay, Fe2 plus is oxidized to Fe3 plus by these bacteria. Okay, so these bacteria are just oxidizing agents, right? They just oxidize. Now different bacteria react at different temperatures. So we can see here a Cdcobacillus acts at around 35 to 45 and so on. So let's do the first question. The first question says, you should know that if you didn't read this question, you can pause and read it properly, okay? So the first question is, suggest a natural habitat for organisms such as thermosulfidooxidants and asthmaticals, these ones. So you can see the temperature is 45, 95, so it's really high range. So this one should be in regions like hot springs, right? Like in Arusha, hot springs. So those are the kind of regions where these bacteria can be found, right? In the hot springs and so on. Then we have this another question here. Why all three species of bacteria rather than just one species are mixed with all in a bioheap? Why do we mix three species? Now there should be valid reasons, because the marks there are 3 marks here, so we should have many reasons, not just one. So probably we can write them using our ink here. So the reasons can be as follows. So it's as follows. We know that this heap normally heats, right? So the survival of the bacteria in a higher range, in higher temperatures when the heap heats up, right? The heat heats up, and so the production increases, right? The production increases. So you can see the production of gold, okay? The oxidation process increases. The production increases. The production of what? Of gold, right? Of gold, because more oxidation, more oxidants will be present. And so on. You can have many versatile reasons. Like it depends on your own ideas, but then the reason should have inclined to these ones. Okay, each bacterium grows at a different temperature, and so when the heat heats up, okay, the temperature kills one species of bacteria, others are still active. So each bacterium grows at a different temperature, and so when the heap heats up, some will be dead, some will survive, and so the ones survive will increase oxidation of heap. The oxidation, they will just go on to oxidize, and more production or more yield of gold obtained. That's all. And even if you have 3 species, in short, if you have 3 species, the oxidation process will take place more often, and there will be more yield of gold produced. Hope that is clear. And then We have another question here. The rate of oxidation of the iron in iron sulfide was compared in the presence and absence of ferrooxidants. The results. So in presence of this one, in absence of ferrooxidants, right? So we should say that when ferrooxidant is present, the rate of oxidation of iron is high because the concentration of Fe3 plus is high, right? That's the first point. Now you should know that when you are given 3 marks in this the question which require you to evaluate data and then give you the result from the data, these kind of questions require you to quote some data. Okay, so after mentioning the general trend, which is when the as the time goes on, the concentration increases in the presence of ferrooxidants more than when the ferrooxidant is absent. You should know that it increases in both the process, but when ferrooxidants are present, it increases more, right? So you should mention that when ferrooxidant is present, the concentration of Fe3 plus increases, so probably the rate of oxidation of the iron increases. That's the first point. Then you can say that however, in the first 15 days, the rate is very smooth, where in the last 10 days, there is a steep increase in the case where the rate of ferrooxidants were used. Okay, here the increase is larger, okay, compared to when it is not used. Okay, so hope that is very clear. And then you can quote some data that it goes up to certain value and all that. Then explain why bioleaching is used on a large scale throughout the world. So why is bioleaching preferable? First thing, now this question is very common and it's easy. Why bioleaching? Because it's cheap, it's affordable, right? You don't need much expense to get this ferrooxidant. They're very cheap compared to using furnaces and all those other processes. Can take a long time, or processes like electrolysis to separate iron, to separate ores, can take a lot of expenses. So this one is very cheap. Okay, it's very cheap, and other reasons are given here in the marketing scheme. We can just refer to them. They do not require energy input. There is no any energy input. It is cheaper. It does not require energy input. You just have to keep bacteria. You don't have to keep any combustion, any combustion engines. Okay, you just have to keep bacteria, and that's all. And then does not require other chemicals to be purchased. No other chemicals required. You just need bacteria. While in electrolysis, you require sodium hydroxide, you require sodium chloride, you require other chemicals as well. But here you don't require. Okay, does not require specialist equipment. No need of, as I said, no need of those electrodes and all those things. No need of specialist equipment. You just take this oxidant, this bacteria, you keep them inside anywhere. You can keep in any container. Okay, it can be done in exactly in the same region where the mining took place. Okay, then less labor needed. Even this is understood because bioleaching is at the same point, so obviously less labor. Then self-replicating. Bacteria are self-replicating, so that's a good thing. They can I mean, the concentration increases. The chemicals used in electrolysis will never increase themselves, but these bacteria, since they are living organisms, they reproduce, so they are self-replicating. So sometimes we will have a lot of bacteria, and so it becomes more cheaper. Okay, and then environmental friendly than other methods. No harmful emission. This is also understood. WHO really recommends this method. As we know, in the mining regions are very harmful. I mean, they are very health problematic, and many miners die of problems like cancer. So if these kind of methods are used, there are less risks of such problems. Then useful for extraction from low-grade ores. Okay, so low-grade ores, you can even, normally what miners do is they throw away the low-grade ores, but then if you have your bio-leaching process, you can even work with them, okay, because it's very cheaper, so you can manage to work with them. Then we have our last question, and this question I'll do it in the next video, because this video is already over 10 minutes. So thank you for listening, and hope to see you in the next video.